In this video, we're going to be going over problem number 2 of your study guide, graphing exponential functions. So let's go ahead and get started. It goes on to say, sketch the graph of the function using the appropriate x and y table. Identify the asymptote and y-intercept. List all transformations, state the domain and the range. Okay, so let's go ahead and let's do just that. Okay, so let's go ahead and start with the negative. The negative, every time you see a negative in front of the leading coefficient happens to be 0.5 in this scenario, a negative is always going to denote a reflection across the x-axis. So let's go ahead and take care of that. Let's go ahead and write, you know what? Let's go ahead and write list of transformations. And so the list of transformations is going to have a reflection across the x-axis. In addition to it, so we have 0.5. 0.5, if we were to take that number and we were to turn it into a fraction, well, let's go ahead and go through the steps. 5/10, we simplify it, we get 1/2. And it just so happens that when the value of a lies between 0 and 1, so think about that logically. Anything between 0 and 1 is either going to be a decimal or a fraction, right? Every time that happens, we have something called vertical compression. So let's go ahead and write that down. So that is your vertical compression. Okay, so now let's move on to now, we have an understanding that because the value of b, and in case you guys don't understand what I mean by a, b, the parent equation of this over here would look like this, a, b to the x power, okay? The value of b, think of it as the base, is 4. It's greater than 1. Therefore, you know, we have an understanding that it's going to be exponential growth, okay? Anything, if it would have been 1/4, it would have been exponential decay. Okay, so let's go ahead and move on to the x plus 3. X plus 3, if we were to solve for the value of x using the zero product property, let's go ahead and do it down here. You guys understand that that would make an x is equal to -3. So what that's telling us is that we have a horizontal shift, and it's going to be 3 units to the left. So 3 units left, because it's negative, right? And then let's go ahead and look at this +2. Well, that's the easy one. That one's telling us that it's also going to have a vertical shift, and it's going to be 2 units up. We don't need to solve for that one. And so there you have it. Okay, so now we have listed all of the transformations. And that happens to take care of this over here. So I'm just going to go ahead and cross it out. Okay, so before we state the domain and the range, what I want to do is I want us to come up with a table of values. So let's go ahead and do that. But let's go ahead and plot our shifts first. So now keep in mind that the original graph for exponential growth is going to look something like this. And there exists an asymptote where y is equal to 0. Okay, but because of that +2, we are shifting that asymptote that used to be at y is equal to 0, and now it's going to be moved up to 2 units up. So now we're going to be able to see it. And there you have it. Okay, so I'm going to go ahead and erase this because I need space to work out my problem here. Okay, so what I'm going to do is, now, in addition to that, you know, the original point happens to be at, the original y-intercept happens to be at 0, 1, and we have actually moved it to, we have shifted that point. It has now been moved 3 units to the 3 units to the left, and then 1 unit up. So if you think about it, here you're at 1. So if you shift this point 2 units up, now you're going to be at 3, right? And you would be right over here. So that point ended up going from 0, 1 to -3 and +3. Okay, but you know, that doesn't really, it's not really going to matter because we're going to have to solve for the y-intercept a little later. Okay, so now let's go ahead and come up with the x and y values. Okay, so what I'm going to do is I am going to select the following numbers. I am going to select -5, -4, -3, -2, and -1. I'm going to bring out my calculator. And all that I'm going to do, you guys, is the way that I see this expression over here, that's how I'm going to input it into my calculator. All right, so let's go ahead and do this. And I'm going to show you guys what happens. Okay, so now let's go ahead and do negative 0.5 open parentheses 4 exponential growth, and this is going to be to the power of, and since we have a binomial for x plus 3, it is best to always have that as an exponent. I mean, inside of parentheses. So my first number is going to be -5. So I'm going to input -5. And then I'm going to go ahead and do +2. Close that parentheses. And then I have +2. All right, and then I'm going to press enter. And so that's going to give me something that's very close to 2. So I'm going to go ahead and I'm going to be plotting this point a little later. You know, you could do 1.99. Usually the rule that I have with my students is always go 3 decimal places. And if, you know, the third decimal place happens to be 5 or larger, to give 1 more to the second one. But it's okay for us to round this to 2, okay? All that I need to do now is, instead of typing in everything again, because that takes a long time, there should be a way to recall back the expression. And then all that you need to do is with the up arrow, you just go to your x value, and you want to go ahead and change that to your next number. My next number is 4, and then I'm going to press enter. And so that's going to give me 1.97. Okay, and then I'm going to go ahead and repeat that process. I'm going to navigate to my -4. This time I'm going to select -3. And so I'm going to end up with 1.88. And notice on how the numbers are starting to descend, right? They're starting to go down. Okay, let's go ahead and do that again. And you guys please follow along, understand how to input these values into your calculator. That way, when it comes to the day of your test, you'll know exactly what to do. All right, let's go ahead and do that. One more time. Oops. Just lost my calculator. All right, so here we go. So now I'm gonna need, what is it, -2? So now let's do -1. And I ended up with 0. And you guys can go ahead and, you can add as many points as you would like to add. And so what I'm going to end up with is going to be coordinate -5 and 2, -4, 1.97, -3, 1.88, -2, hold on one second, if I input -2, I get 1.5. If I input -1, I get 0. And that should be good enough. Okay, so now let's go ahead and, let's go ahead and graph this. And let's see what we get. Okay, so at -5, and I'm going to be using a different colored pencil. So -5, we're going to be at 2. Now, keep in mind that it's, it would be impossible to be at 2. As a matter of fact, you know what? I am going to retract my, my 2. I am not going to round it. And the reason is because we have an asymptote there. So I think it would be best to just leave it as 1.99. You guys see that? See, I wouldn't be able to plot it exactly at 2. It's going to be very close to it, but it's not going to happen. Then we're going to have -4 and 1.97, so just a little bit below. -3 and 1.88. -2 and 1.5. And at -1, we're going to be at 0. And let's see, and you guys understand that this graph is actually going to continue, I don't know, going like this. All right, so, you can go ahead and continue plotting points and that would be fine. Okay, so in addition to it, we're actually almost done with this problem. What we need to do now is we need to state the domain and the range. Well, it just so happens that domain talks about all of the x values, okay? So this graph is actually going to continue growing forever and ever and ever along the x-axis. And so for this graph, we can go ahead and say that it's all the real numbers, or we can go ahead and write it as -infinity to +infinity. When it comes to the range, unfortunately, the range, does not get, from infinity to +infinity. If you notice, there's an asymptote over here, and the asymptote does not allow the graph to go through this point. And so what's going to happen is, it can only go from where, from 2, and it's going to be to, oops, I actually made a mistake there. 2 is not included. And so we're going to open up a parentheses and we're going to say from 2. And as you guys understand, it's going to be going down, right? The range is always all of the y values. So we say that it's going to be going towards -infinity. Okay, now there's a very important point that you guys need to pay attention to, and that's going to be the y-intercept. Now, for the y-intercept, well, that's actually not too difficult to compute. For the y-intercept, what you need to do is you need to let x equal to 0. So if we let x equal to 0, let's go ahead and add it over here. This is going to be the y-intercept component. I'm going to need my calculator again, so I'm going to bring it back over here. And what we're going to do is I'm going to recall my expression. Oops. And then I'm going to navigate to where this over here is 0. By the way, your calculator would actually accept -0. Okay? Because remember, 0 is the only number that can have both positive or negative. And what's the reason for that? I don't know. God forgot to baptize it. I don't know. Okay? But, okay, so now we know that by inputting, here, let me show you guys. Okay, so I inputted -0. And now let's go ahead and go to 0 again. And let's delete that negative. And then you end up with the same number, okay? And so our y-intercept is going to be at -6. One of the reasons we want that is to make our graph a little bit nicer. So we know that this is going to continue going down. And let's say that -6 happens to be there. So the graph is going to cross through there. And there you have it. I believe, let's see, we have domain, we have the range, we have listed all of the transformations. The asymptote happens to be, I guess I forgot about that. The asymptote is where y is equal to 2. That's where it exists. And we have come up with an appropriate x and y table of values. And there you go. That is we have addressed everything. Okay, so that was the first problem. Now let's go ahead and move on to the second problem. Second problem is actually a lot easier. Let's go ahead and read it. It says, select the exponential function below that best models these characteristics. And it goes on to say it has to have a horizontal asymptote where y is equal to 2. Okay, so let's start eliminating a few. Look at that. That is where y is equal to 2. So letter B cannot be it. This one over here, yep, can't use that one. Cannot eliminate it. And we cannot eliminate that. The only one that we can eliminate is letter D. And it's because it doesn't have a +2. All right, so now we have a better chance of getting this right. Okay, and then it goes on to say it has to have a y-intercept at 0, 4. It has to have a y-intercept. Okay, so let's go ahead and use our calculator. Now, I won't know, not until I input the value of 0 into my expression, and then I end up with a 4. So I want to be very clear about that. You know, you're just going to have to input the expression 2, and then we're going to have 0.25, close parentheses, and it's going to be to the power of 0. And then we're going to be adding 2. And there you have it. So we know that it's going to be, that this one's also good. Okay, we know that it could be A. But then again, it could also be, let's go ahead and go with B, see what we end up getting. In this scenario, we're going to have -2, and it's going to be 4, and it's going to be to the power of 0, and then +2. Yeah, it's not going to be that one, right? So, you know, and I'm only basing this on the intercepts. Okay, it could be C. I don't know. Let's try it. 4, 3, and let's go ahead and do to the power of, and then let's go ahead and do negative what? Zero, and then it's going to be +2. Yeah, that made a 6. So by process of elimination, I can already tell you that the correct answer is going to be letter A. Okay, but there's one more clue that they're giving us. So again, by process of elimination, we know that it's going to be letter A. Now, always decreasing on its domain. Always decreasing on its domain. Let's go ahead and graph it and see what that's all about. Okay, so the first thing that I want to do is I want to go ahead and take care of my horizontal shift, vertical shift. So this graph is going to be shifted 2 units up. And so my original y-intercept happens to be there. And so we're going to move this point also 2 units up. So now we're going to be at +3. Nope, 2 units up. 1 and 2. Sorry, we're going to be at 4. Okay, so, and there's no horizontal, right? And so it just so happens that it goes on to say always decreasing on its domain. And so what's going to happen is that, you know, decreasing on a domain means that it has to be exponential decay. And there you have it. I hope you guys have found this video helpful. And in the next video, I'm going to be working out problem number 3.